and welcome to Start to C with tSQLt, where we'll dive into the world of unit testing with SQL Server databases. Unit testing has been around for applications for decades, but unit testing with databases is fairly new. So, for the next 60 minutes, we will be talking about why this is so important. We will look at unit testing and integration testing. We will look at some tSQL code, tSQLt code, and in the end, we're going to do some demos. Well, I'm Sander. I'm a SQL Server DBA living in the Netherlands. I'm a Cloud and Data Center MVP, and I work for Waypoint Analytical. I'm a major contributor to the DBA Tools project, and if you want to follow me on Twitter, this is my Twitter handle. I have a blog, and if you have any questions after this session, please send me an email. I love questions. The one question I can already answer for you is all the demos that you will see today are going to be available on my GitHub page. Go to my GitHub, go to presentations, look up this session, and you will find it there. So let's look at unit testing and integration testing. Unit testing is the testing of a small piece of code. It's a single component and the scope is very narrow. It's a small effort to put together and it mainly focuses on testing specifics in your code, like a particular part in your store procedure or anything like that. Integration testing, on the other hand, tests different pieces of code. Maybe the interaction between different store procedures, like modules, will be considered. The scope, because of that, is very wide and it's a larger effort to put together. You really need to know the interaction between these different components. And it really tests that little interaction. And because of that, it's a little harder, but in the end, it will give you a lot of benefit. So why is this important? Well, it makes your process more agile. When you add more and more code to your existing database, changing any existing code is both risky and costly. But if you have unit tests in place, you can test for any changes and the refactoring of that code will be done confidently. The second reason is that it will increase your quality of code. Writing tests before you're coding anything really makes you think about the problem. And it exposes those edge cases and makes you write better code. Another reason is that you will find bugs very early because developers are developing on their own test system or on their local system. Before they push anything along the pipeline, they will find these bugs because they have the unit tests. It will facilitate changes and simplifies integration. And unit tests detect changes and they will see when you may break some kind of design contract and to help you maintain and changing the code. And unit testing really reduces the defects in the newly added code. It provides documentation. Developers who don't know how specific code works may be able to look at the tests and figure out what the specifics are that you try to accomplish with that code. Another reason is that the debugging process will be very easy because only the latest changes that you put in are going to break anything. So that's going to make those bugs. And it makes for better design. Because we're writing the tests before we code, it will define what the code is responsible for. And if you can do this easily, the code's responsibility is well defined and therefore there's a high cohesion. And in the end, it's going to bring down costs because fixing those bugs in production or later on along in the pipeline is very costly. So the faster we are able to get these bugs out or any defects out, it's going to decrease our costs in the long run. And one reason I really want to emphasize, you cannot write high quality software on a large scale without unit testing. Period. You can debate me on this. So, what does unit testing improve? So, these are the areas that it improves. It's going to be the visibility and the reporting is going to be better because you can visually see what's happening with those unit tests. You will see what's happening and you can report on that. There's more control and correction because before you push anything along the pipeline or to your repository, you are able to see what failed, and you'll be able to correct that in a timely fashion. Because of that, the efficiency and the speed of your deployments will go up because we no longer have to go back to fixing all kinds of bugs. And if you do the proper unit testing, the chance that that happens is going to be very slim. And because of that, the planning and the predictability of your releases will go up. If we have to go back, that's going to create scope creep and all these kind of things. So it's going to improve these areas. And in the end, that leads to better customer satisfaction, right? And that's all that we want. So what makes a good unit test? Well, first, we have to run the entire collection of tests. We just can't run a single test and say, okay, hey, the new code works. No, we have to run the entire set to see how that all relates to each other. It must be executed without any manual intervention. So as soon as you run all the tests, it should just run. You shouldn't have to put in a value or you shouldn't have to click anything. It just should run. And the results have to be unambiguous and repeatable. So what happens is that if you get these results, you should not have to have a discussion if these are correct or not. And it should be the same process every single time. So what's the anatomy of a unit test? It has three parts. We have the assemble part, where we assemble all the code we need to do our unit test. In this case, we have two variables, and we're going to fake or mock a table. And we're going to set the expected value. These are the components I need for this particular test. Then there is the act part. And in the act part, I run what I want to see that needs to run. In this case, we are going to execute a store procedure, and the output of that store procedure is going to be saved in a variable called actual. And in the end, we're going to assert these values. So we say, okay, tSQLt.assert equals, and then we have the expected and the actual value. And these have to be the same. If not, our test fails. So what is tSQLt? tSQLt is a unit testing framework specifically for SQL Server databases. It's developed by Sebastian Main. I hope I pronounced his name correctly. And it's an open source project, so you can help if you see any bugs or want more features. And I like tSQLt because it keeps the database developer in its tSQL bubble. They don't need to learn another language like PowerShell or C# to do these unit tests. So the hurdle to do these kind of things is going to be very easy. So what can we do with tSQLt? First of all, we can mock tables like we saw in the previous slides. And we can do the same thing with functions and views, store procedures. We can assert tables and data sets. We can assert values, but also the existence of objects, it may sound odd, but it's really powerful because I want to know if an object is there. I want to know if my table or my store procedure or my view is there because that could break other stuff. And we can handle exceptions. And we always want to test the happy flow, but I want to know if I put in a wrong kind of value in my store procedure, for example, that it will generate that error that I'm expecting to get. So in the demos, you will see how that looks. And we can return the results in a format that can be interpreted by any build server. And in this case, the default is going to be the JUnit test result format. And build servers like Azure DevOps or Jenkins are able to interpret these values and show you in a graph what happened. So that's really powerful. So what are the requirements? We don't have a lot of these. So the first thing you have to do is enable CLR on the test instance you're running the tests on. That's basically it. So just enable CLR and go. The second thing is install tSQLt into the database. It's not installed on the instance, it's per database. You need at least one test class. And test class is basically a schema that holds your tests. And we need at least one unit test, which makes sense. Otherwise, why install tSQLt in the first place? So some tips before we go on. Create multiple test classes. I always like to separate my unit tests in basic and unit test / integration testing. My basic tests will be something like existence of objects, the correct table columns, correct store procedures, store procedure parameters, all these kind of tests that you assume are correct, but should be done. And the other one is going to hold the more sophisticated, more manual unit tests where I dive into the functionality of each object. Give the test a descriptive name. Don't call it test 01. You have 128 characters to name your test. So call it something like test if procedure X creates object Y, something like that. Make it descriptive because that's going to be easier in the end to see what test failed in your results. Begin each test with test and then ... That makes it easier to overlook all the tests. And only one assertion per unit test. And this one is important. Do not make the mistake to create multiple assertions in a single test. Create multiple tests. Because if you run the test and you have like 10 assertions, it could fail on the first and then on the fourth and then on the seventh. And you will see the same test fail and not specifically know what part failed. So you have to dive into the code, figure it out, and just write multiple tests. You have over 2 billion objects that you can put in a SQL Server database. So why bother if you have like 10,000 tests? It's not going to be in production, so it's going to be on your test instance anyway. So let's go into a demo. Let me switch this. There we go. So what we're going to do is we are going to do some preparation. I made these PowerShell or the SQL notebooks to make it easier for you to execute from Azure Data Studio. So we're going to create our database. Let's connect first. It's easier. I'm going to connect to my localhost. Run. Then I'm going to create my database. I am going to create a bunch of objects. I'm going to create a person table and a customer table. And I'm going to make a foreign key. Then I'm going to create the procedures. My first procedure is going to create a person, and the other one is going to get all the persons. These are just examples. It's done. Okay, we can close this one. And now let's install tSQLt. Like I said, we have to do a couple things for the requirements of tSQLt, and this is one of them. I have to enable CLR. So let's enable that. Oh, first change the connection. That's it. So if you don't have it enabled, it will say change from 0 to 1. In my case, I already have it enabled. Because of 2017 and up, there is another configuration that we have to set before we install. We temporarily have to set the SQL strict security to 0. And then this is the tSQLt script that we're going to install. So we're gonna run this script, and it's going to generate a lot of data. There we are, commands completed successfully. It does a lot of stuff. And then at the end, if it's all successful, it says, thank you for using tSQLt. And like I said, we only had to set the CLR strict security to 1 temporarily because of the installation. And now we can set it back. Done. So now we have everything installed. So it's from 0 to 1. Okay. This is it. That is to install tSQLt in a database. Do not do this in a production database. Please don't do that. Now, the first thing we need to do is create a test class. So I always want to do 2 of them, like I said before, a test basic and a test. And in this case, it's going to be test and then my database name. So let's create that one. Local hosts. This test class. And basically, these are schemas. So if I select the schema ID, I see that I have 2 test classes. So my test classes are created. Now we can continue. Let's create our first basic unit test. Just to do some cleanup, I am going to say, okay, drop these if they exist. And my first basic unit test is going to check if my table exists. So it's going to say test if table dbo.customer exists. But this is going to fail because I made a typo. It says customers, and we'll see what happens if I run that. Another one is going to be successful because it's going to be dbo.person. That table does exist. So if I run this, and I can run this with tSQLt.runAll, and this will run all the tests. Hey, indeed, my tests failed. My dbo.customers does not exist. And in the summary, we can see, okay, we had 2 test cases, 1 succeeded, 1 failed, 0 errored out. The difference between failed and errored is that if the assertion fails, you have a failed test. If it errors out, there's something else seriously wrong with your test. So it took like 30 milliseconds and 0 milliseconds to test this. So about 3 seconds in total. Okay. Now we know that our test fails. Let's fix it. So instead of customers, we are going to say customer. Let's run this. And now if we do tSQLt.runAll, it should be successful. Yes, it is. 2 succeeded. We did a good job. Now, we can run all the tests, but we can also run specific tests. And what you need to do is say tSQLt.run with the test name and then the fully qualified test name, including the class and the test class and the entire name of the test. If you run that, it should be successful. Yes, it is. So this is how you can test a single test. If you have a lot of unit tests in your database, you may want to see if your new unit test or your currently failing unit test is succeeding afterwards. You made any changes. Okay, these are a few simple basic unit tests. Let's go into another one that I like to do, is that I want to test if a table has the correct columns. So let's do some cleanup. And we're going to test if dbo.person has the correct columns. And why do I want to test that? Consider someone changing a varchar field from 100 to a 20, and all your values in there are at least 50 characters long. Then there's going to be a lot of truncation, and fixing that and cleaning that up is going to be a problem. Most likely you have to do a restore of the database to get that fixed. So what it does is I create two temporary tables, one actual and one expected. And into the expected, I insert all the columns that I have in my table with their name, their data type, the length, size, and the position. And in the end, in the act part, I'm going to insert all the values directly from what I have. And then there is an assert called assert equals table, which looks at the expected and the actual temporary table. So if we run that, that's created. Let's run the test. That's successful. Cool. So if there's anything wrong, it will tell you, hey, I was expecting this row. And we'll see that later on in another demo, because I'm going to do more with the assert equals table assertion. Let's run all the tests. Okay, we are still good to go. Let's test for store procedure parameters. Let's connect to my host again. And this time it looks similar to the one with the tables, but instead of using any column data types, I'm going to say add person ID or add another parameter name. And then I'm going to collect these from the sysparameters table and assert equals table again. By the way, you don't have to sort any objects. That's all handled in the background for you. tSQLt will know which values are not in the expected and the actual data set. Let's run the specific test. And we're successful. Let's run everything. And we're still good to go. I'm going to save that. So now we're going to go into more specific unit testing. So as you can see, this is a different task class. So I'm going to go and save this in another task class. Let's change that. See if it exists. And this time it looks similar to one in the slides. I'm going to declare two variables. I am going to mock a table. And I want to tell you some background how this works. All the tests work in a transaction, which means that if you run this test and you mock a table, the underlying table that's in the database is not going to be changed. So if I insert anything or I delete anything from that table or I change any data types, that's not going to reflect to the actual database itself. It's all in a transaction, and afterwards the transaction is rolled back and you have your test result. So we're going to mock that table. We're going to set the expected value, and then we're going to execute that store procedure. And then I'm going to do an assert equals, and I'm for the expected and the actual value. Let's run that. And now we have another successful test. And this is how you can do your specific unit tests, test functionality of that store procedure or function, anything like that. Let's run all the tests. And you can see that it's really fast. It's less than a second to run these tests. It takes more time to click the button. So let's test for failure. And this is the next step in your unit testing, because if you're testing for failure, you're doing it the right way. So we are going to create a test called create person without first name should return error. So what we have to do is I'm going to fake a table. I don't want to change anything in the underlying table. And then I'm going to set the expected exception. And my expected exception is going to be invalid parameter at first name cannot be null. And when I do this, the act part, I am going to leave out the first name in this case, and I should get an error, which is good. And that was successful. Cool. Let's run all of the tests. And now we have like 6 successful unit tests. But how does it look in the JUnit format like I mentioned before? We're going to run the tSQLt.xml result formatter. Let's copy this. And I'm going to put this in my results. I'm going to save it and then format. And as you can see, it has a test suite for every test class that we have. And we can see that we had 4 tests, 0 errors, and 0 failures. And this format can be interpreted by a variety of build servers. So this is a very common way of doing it. So let's close that one. Let's create something with datasets. So I'm going to connect again. Okay. In this case, I am going to insert values into my table. Again, if I'm going to mock this table and insert values, these values will not be inserted in the actual table. It's all going to be in a transaction. So these are my values that I'm going to insert. I'm going to create an actual table which represents the same schema of my current table. And then I'm going to say, okay, select all from dbo.person into expected. This is the same query I execute in my store procedure. So you want to take that code, put it in your act and in your other parts and see what happens. In the act, I'm just going to execute dbo.person get all, which is basically this query. And then I'm going to assert equals table. That is executed. And I'm going to run it. And of course, it's going to be successful because I knew what's going to happen. We could test this another way. Instead of doing this with an assert equals table, we can do a count. So if you're expecting 4 rows, you should get 4 rows. So the same kind of setup, but instead of doing anything with data sets, I'm going to say, okay, I'm setting a row count. It's going to be a count of the entire table, and I'm expecting it to be 4. And then I'm going to set the actual to row count. Let's execute that. And we're good. How does that look if we do anything and break it? So we did something previous with the assert equals table, but how does that look like if we do that a little different? So we're going to remove one of the rows, and you shouldn't do this in your actual unit test because it's going to break it. But we do, for demo purposes, I am going to delete the first row. And if I execute that, then we have something that we call unexpected and missing result set rows. And as you can see, I'm missing this row, and this is the indicator that you're missing something. If there is a row in that table that shouldn't be in there, then there is the other arrow, this other side around. Let's run everything. And of course, we have a failure. Let's fix that though, because I want to have clean code. So I'm going to create it. There we are. run everything. And now we're good to go. We have 7 succeeded tests. But now we have a developer, and he's going to change some things in our tables. And by accident, he changes the column to a varchar 20, which originally is a varchar 100. Let's run the test. And I had a test for the table columns. So what's going to happen is test if table person has the correct columns has failed. And this is what I mentioned, that with the rows that I wasn't expecting and the ones that I was expecting. So this one is missing and this one is in here. So immediately we will know, hey, something changed here. Either I have to change my test or I have to fix what I just changed. So let's put it back together and run the test. And now again, we have some successful tests. Cool. This is in a short demo how you can use tSQLt for all your objects. But that is going to be pretty tedious. So let me do some cleanup and I'm going to show you how you can automate that. There we go. We're going to create the same database because I have all these objects in there and I don't want all the tSQLt stuff in there. So there we go. We cleaned it up. And now we're going to go to use PowerShell. And I love PowerShell to automate things. So what did I do? I had to create SSDT solutions for all our databases, which was over 35 of them, which is a lot of work. You have to go to Visual Studio, click New, Solution, put in a name, create a project, import everything, put in the test framework and everything. That took like 10 minutes per solution, and that took a lot of time. So what did I do? I used the PS module development PowerShell module to templateize our entire design or architecture for our SSDT solution. And with some tweaking and some GUIDs, I was able to get that template working. And now I can generate an SSDT solution in a matter of seconds. And this script downloads the latest SSDT template. You can download it, by the way, from my GitHub page if you're interested. And this will download it, extract it, and install it for me. And the most important command in here is invoke psmd template. It needs the template name, the output path, and the name. And if I run that, say 01, create SSDT project. It's going to download it. And done. You couldn't do this manually faster. So let's open that project, shall we? So we're going to open that with Visual Studio. And it's going to interpret the values and the projects. This is going to take a couple seconds. Preparing the solution. And now we have our solution open and we can see that we have 2 projects in here. One is the data model and one is the tests project. And I want to separate these because I want, if I would do any builds in a CI/CD pipeline, then I want to be as flexible as I can be by either building my data model or my tests if I want to do any tests. And I don't have to import all my objects twice. I have made a reference to this project in this project. So all the objects that will be in here will also be in here. So I only have to do an import on the data model. Select the connection. This time unit testing, and I'm going to say just object type. Let's start, and this takes a couple seconds. And we're done. Now we have our store procedures and our tables that we created earlier. But we still don't have our basic unit tests. And this is where my hate for repetitive tasks comes from. I hate to do repetitive tasks. So what did I do? I created a PowerShell module called PSTG test generator, the tSQLt test generator. And what this does is it takes the current state of your database and then gets these objects and then looks into them and creates these basic unit tests for you. It generates them. And it generates tests for the accesses of objects, database collation, for instance, function parameters, store procedure parameters, index columns. All these tests that you saw before are going to be generated. So let's see how that looks like. I'm going to see. Nope, that's the wrong one. Create unit tests. By the way, this PowerShell module that we'll be using here is freely available through the PowerShell gallery. You can just say install module ps tSQLt test generator. There we go. Store procedure, existence. And this takes a couple seconds. You can see it does indexes too. There we go. And we're done. So we can import these and say, okay, add my existing items. I'm going to go to my test basic. And I outputted the tests directly into this directory in the demo. It's just easier for me to do this. And let's look at one of these tests. So one of them I created was the database collation. If my project has a different collation for any of the tables or anything like that, that's going to be a big problem when I do any deployments. So it saw that this was my collation, and in the act part, it's going to select that from the database property, and then it's going to do the assertion. It's that easy. So if I do a deployment, if I say, okay, let's go down to my publish profile because that's also in the template. Let's deploy that. And in the meantime, I am going to connect to my local host. I'm going to say new query. I'm going to say my database is not yet there. Let's say use unit testing tests. Let's say publish to my local profile. So in the meantime, I'm going to write this query. Go, and then I'm going to say execute tSQLt.run all. Let's put some brackets around here. Are we done? Almost. It's deployed, and let's run the code. And there we are. Let's make this a little less big so we can see all the tests in a nice formatted result. And this is your test result. So we've done the entire creation of SSDT solution and the tests, and we did a deployment. Pretty easy, right? So let's go back to our slides. Oh, not that. we go. So what did we use? We used tSQLt, which is available from tSQLt.org. It's freely available and it's even an open source project. We used the PS module development PowerShell module, which can be downloaded from the PS gallery, and that's part of the PS framework. We used the SSDT with tSQLt template to create our SSDT solutions within a matter of seconds. And this will really speed up your development and your deployments. And another thing I would need to mention is that the template for the SSDT with tSQLt also includes an Azure Pipelines YAML file, also completely generated for you for testing all your changes with SQL Server 2017 and SQL Server 2019. So you're good to go and you can start right away. I hope you find this interesting and I hope you enjoyed this session. And if you have any questions, you know how to reach me, and I love questions. So I hope you have a nice day and good luck.